In this section, we learn our third way to find limits, and that is using algebra or algebraically. And in order to do that, we need our limit laws. And so I just wanted to take a moment to go over these very, very briefly, especially the first two, because it should be very conceptually easy to grasp. So the first one says that if you're taking the limit as x approaches a of the function x, you're going to get a. And think about what this picture looks like. Here we have our axes, our y-axis and our x-axis. And remember, the function f of x equals x is just the diagonal line that goes through the origin. And this is the line that y equals x. So y value is always the same as the x value. So if you're approaching any a value, okay, so let's say we were approaching 1. From the left side, that corresponds to this part, you're going to be approaching 1. And from the right side, you're also approaching 1. So the limit as x approaches 1 of x is just 1. And you could do that for any value of a. So the limit as x approaches 20 of x would just be 20. Okay, let's look at the second example, or the second law. And that is that the limit as x approaches a of c equals c. Now, what is f of x equals c? F of x equals c is just some constant function. So, for example, f of x is equal to 3. Okay, so remember, a constant function, y equals 3, would look something like this. It's just the line, the horizontal line that goes through y equals 3, right? And so it does not matter what we're approaching. If we take the limit as x approaches any value, the y value is always going to be 3. So in general, if you take the limit as x approaches a of some constant function, the answer is always going to be the value of that constant function. I'm going to take a moment just to highlight a couple more of these so that you can see how they work. But let's look at the sum law for limits. If we took the limit as x approaches a of f of x plus g of x, so we have a sum of two functions, then we could actually take the limit of each function separately and then add them together. That's what that limit law is telling us. So if this answer here for this function was L, if that was the limit, and if this limit was M, then your limit of the sum of the two functions would be L plus M. Using that explanation, hopefully you can look at the rest of these and make sense of them. Something to note is with the quotient law for limits, the limit of the denominator cannot be equal to 0 because we can't have a 0 in the denominator. Other than that, you're probably wondering how we'll use these limit laws. So stand by and I'll cover a few examples for you. Let's look at a quick example. Suppose we had the limit as x approaches 2 of 2x squared plus 3x plus 1. In order to do this problem, let's look at the sum law for limits, which tells us that if we have the limit as x approaches a of f of x plus g of x, so the sum of two functions, we can split those up and take the limits separately and then add those limits together. So I see that we actually have, we could write this as the sum of 3 limits if we wanted. So we have the limit as x approaches 2 of 2x squared plus the limit as x approaches 2 of 3x plus the limit as x approaches 2 of 1. And so using now the constant multiple law for limits, I can pull the c out front, the constant out front. So I get 2 times the limit as x approaches 2 of x squared plus 3 times the limit as x approaches 2 of x, and then plus the limit as x approaches 2 of 1. Okay, so x squared is just a parabola, and it doesn't have any holes or problem spots in it, so we know that as x gets closer and closer to to 2 from both sides, the value of the function is approaching 4. Okay, so this is just going to be 2 times 4 plus 3 times the limit as x approaches 2 of x. And to do that one, we can look at limit law number 1 that says if you have the limit as x approaches some constant of your function x, then your answer is just going to be that constant. So we have the limit as x approaches 2 of x is just going to be 2. And then for the third part, we have the limit as x approaches 2 of 1. And for that one, we can use the second law. And so we know that the limit as x approaches 2 of a constant function is just the constant itself. So we do our multiplication, we get 8 plus 6 plus 1, and our answer is 15. Hopefully this simple example shows you how you can use the limit laws to sort of dismantle a function and find the limit of it.